Welcome to the walkthrough for Assignment 4. The purpose of this assignment is to deepen your experience using Java's functional programming features and their integration with Java completable features. In particular, in this assignment, you'll develop an app that uses the Java completable features framework in conjunction with Java sequential streams to obtain and store images. Like the early assignments, the code you'll write here will have a GUI and will run as an Android app. Please use this GUI along with the JUnit test discussed below to help test and debug your solution. The following resources may be helpful in completing this assignment. Detailed overviews of Java completable features are available in videos 57 through 64 in one of my YouTube playlists. And there's also good overviews of Java completable features that appear at these links. I highly recommend you get the book Java 8 in Action, or more recently known as Modern Java in Action, to learn more about Java completable features. Naturally, we're covering all this material in class, which you can get from my YouTube CS891 playlist at this link. As always, we've structured this app as a project using the latest version of Android Studio. I won't go through all this in detail. You've seen it before. You need to take a look at the crawlers folder, which contains the skeletons you need to fill in, as we'll describe later in this video. And there are also various unit tests and integration tests to run to exercise the features of your solution. In this part of the assignment, you'll complete the implementation of the image crawler class, which is located in the crawlers folder in the completable future crawler1.java file. And as before, as always is the case for these assignments, it will perform an image crawl asynchronously starting from a given root URI. And again, you can either have it traverse through links on your local machine or in the web. The bulk of the code for the apps is provided in the skeletons, which we'll describe in just a moment. There's also a complete Java 7 features version that's provided in the sequential loops crawler.java file. And what you need to do is take a look at that file and then use that to help influence the way in which you'll implement the completable features version of this. Take a careful look at this sequential loops crawler implementation because it differs somewhat from the previous version that was provided in previous assignments. So you'll need to take that into account when you revise your Java solution to account for the changes to support Java completable features. As before, you need to implement the methods in the array collector and the unsynchronized array Java files. You should be using no loops at all in the assignment and instead be using Java completable future methods, particularly the factory methods, the completion stage methods, and the arbitrary arity method, all wrapped up with a nice object-oriented collector class, as well as the Java sequential streams. You can download the skeleton code in the usual place from my Assignment 4 folder in my GitLab account. There's a bunch of unit tests, which I will run briefly at the end of this video to illustrate how to run them and what they should do. Of course, be aware that testing only shows the presence of bugs, not their absence. So you need to do other things to make sure your code's working than just run the tests. But that's a good place to start. To kind of wrap up the final assignment, this is more complicated than the previous assignments. In particular, the asynchronous nature of completable features can take some time to get used to. So I recommend starting the assignment very soon. Ask questions in class, come to office hours, ask questions on the Piazza discussion forum, and so on. And even though there's an awful lot of code, you don't have to understand all of it. You just have to understand the parts you need to fill in. But it wouldn't be a bad idea to look more broadly at the overall solution because it's really cool. Now that we've walked through the specifications for Assignment 4, let's go take a look at the skeletons. As usual, you'll have to copy over your solutions for array collector, array split iterator, synchronized array, and unsynchronized array from the previous assignment. Your main focus will be on the completable features crawler 1. Naturally, you'll also have to copy over your solutions for the earlier assignments just so that you can have a comprehensive set of tests. So let's take a look at the skeletons for completable features crawler 1. As you can see, this implementation strategy uses Java functional programming features, in particular the completable features framework and the sequential streams framework, to perform an image crawl that starts from a root URI. And we'll talk about this. We've talked about these features in class, and I'll show you some examples, but this will be the skeleton you'll have to fill in. So the first thing you'll need to do is implement a constant, which is a completable feature which is completed with the value of 0. And you'll see why you need to have that just a little bit later on when you do the actual implementation. Come down here, there's another method you have to fill in called perform crawl. And this will essentially call one of the helper methods that performs an asynchronous crawl. And that will return a completable future. And then you'll go ahead and basically wait on that completable future until everything is done, and then you'll join. So you'll have to figure out how to do that. It's pretty straightforward. Here's the perform crawl async method, which of course is the method that does a lot of the heavy lifting here. As you can see, the first thing it does is it checks to see whether or not you've reached the depth of the web crawling, in which case you return M0, which is this constant you filled in before. You then check to see if you've already seen the page URI. If you have not seen it, it gets atomically put into the mUnique URI's concurrent hash set, and then you keep going. Otherwise, you return 0 if you've already seen this link. And then the last thing that happens here is perform crawl helper is called. And we're going to take a look at perform crawl helper here in just a second. And you'll see that this has got some logic that needs to be done in order to get all the various pieces working. So this logic here will go ahead and asynchronously get the page future, and then in parallel we'll get the images on the page asynchronously and crawl the hyperlinks on the page asynchronously. All those things give back completable futures. And then the last thing we do is we go ahead and combine the results. And that's also done asynchronously. So some interesting stuff that goes on here. So these are all things that are given to you. Now we get to the parts that you actually have to start to fill in. So basically, the getPageAsync method will go ahead and load the HTML page asynchronously. Obviously, the URL or the URI for that page is passed as a parameter to this method. So you'll have to write the completable future code to go ahead and asynchronously get the contents of the page. So you'll have to think about how to do that. Here's a hint. Think factory method. Here is the get images on page async method. And what this does is when the page future that was returned from the previous call to the getPageAsync method, when that triggers, when it's ready, then you want to asynchronously get the array of image URLs to process on this page. And that will require a call to the appropriate completable future completion stage method. And you'll pass in the appropriate action that will get the images on the page. And then when that future is triggered, the future that's returned from then apply async, then you're going to go ahead and asynchronously transform the images that are identified in the URL array that will come back from get images on page. So you'll go ahead and again call another different completion stage method to asynchronously process the images. So you'll have to sort of think about how you're going to do those things. It takes a little thought. I recommend taking a look at the methods below to see what you can use that's already been defined. The next method that you have to implement is the crawl hyperlinks on page async method, and this will asynchronously obtain a future to the number of images processed on pages linked from this page or hyperlinked from this page. And so what you'll do here is when the page future is triggered, then you will go ahead and call another asynchronous completion stage method to go ahead and crawl the hyperlinks on this page, which is a synchronous call, which you can see a little further down below. And that, of course, is called in the context of an asynchronous completion stage method, so that the whole call will run asynchronously. So this will asynchronously and recursively crawl through all the hyperlinks that are accessible from this particular page. And then the next method here is called combine results async. And what you'll do here is you're passed two completable futures, one which is a completable future to the number of images on the current page, and the other is a completable future to the number of images that are reachable via links on this page. And this code will then use another completion stage method that's triggered when both previous completable futures complete. And then it'll go ahead and sum the results and return a completable future to that. So those are kind of the top level methods that you have to fill in. that all essentially are the ones that are called from the perform crawl helper method that we showed below. Okay, so now we're going to start looking at the various non-async methods, although we'll see that there's some async things that are going on in them. But these are methods that will do various things when they're called by those other methods above. So one of the methods is crawl hyperlinks on page. And this particular method is going to take the page that we've been passed and the depth that we have been passed, and it'll take the page and it'll go find all the hyperlinks on that page using one of the existing calls, and make sure you're only trying to find the hyperlinks, not the image links, just the hyperlinks. So you'll take a look at the crawler.page class and find the method that can be used to find all the hyperlinks on the page. You'll then convert that into a stream, and then you'll basically take that stream of hyperlink elements that are on the page, and you will then recursively call perform crawl async. And this will be done in the context of map. So for every hyperlink that's on that page, you will call perform crawl async, which will recursively visit all the hyperlinks on the page. And that will return a stream of completable futures. And so then you'll need to collect that stream of completable futures using your futures collector stream. And so you have futures collector stream, and there's a toFuture method, which we talked about in class, something along those lines. And that will give you back a single completable future that will wait for all those other completable futures that are all crawling things asynchronously to complete. And when that is done, then you'll go ahead and call a completion stage method that triggers on the completion of a single previous stage, and that will then reduce the stream of integers to sum all the results in the list. So you'll end up with returning a completable future to a sum that corresponds to the sum of all the various images that were reachable from that page. Let's take a quick look at the next method here, which is the process images method. What this does is it will use completable futures in a sequential stream to download, store, and transform images asynchronously. So it's going to take the array of URLs, convert the array of URLs into a stream of URLs. Then we're going to do a couple of various methods to get the images downloaded. So for every element in the stream, you'll map those elements by calling a method that will download and store each image asynchronously. So you'll end up with a stream of completable futures to images that are being downloaded. Then you will go ahead and map that stream to transform each image asynchronously. And then you can go ahead and collect all those results together. So we're downloading asynchronously. As those things complete, we're transforming asynchronously. And then once again, we're going to use the collect method to collect all of those streams of completable futures into a single completable future that will be going to be to a streams of images. So this is a little bit tricky. Once that completable future will complete, then you're going to go ahead and take that stream of images, and you're going to call a completion stage method, which will flatten that stream into one stream. So you'll have to use the flat map method with function identity in order to be able to flatten the stream of streams into a single stream, and then you will return a count of the total number of images processed. And of course, this will be wrapped up in a completable future as well. So this is a little bit of a tricky method, so you have to think about how you're going to do that. And then down here we have another method. This is the final method in this file, which is the transform image async method. And it's passed in a completable future to an image. And when that image future is triggered, in other words, when we're done with downloading the image, then we're going to go ahead and call a completion stage method that will essentially take the list of transforms, which is the image filters that are going to be applied, convert that list of, or that array of URLs into a stream, and then we're going to go ahead and essentially create a new cached image and then we're going to apply the transform to it asynchronously. And yet again, at the end of this basically sequential stream, we're going to collect all the results together up into a single completable future. And so we're going to have a single completable future that will wait for all the other completable futures that we're transforming asynchronously to complete. So that's basically the methods. These are some tricky code. It's not that there's that much code to write. It's that you really have to get your head around all the asynchronous operations. And so you've got to be able to figure out how to call the methods asynchronously, and then how to be able to collect them together into a single future to a bunch of completable futures, all of which are running in the background. So that futures collector stream class is very helpful. And that class is actually given to you over here. This is very much like what we've talked about in class before. It essentially has an array list as the mutable result container, and it has the special magic here in order to be able to essentially convert the array of completable futures into a single completable future. And then you can see here that we go ahead and return this as a stream. So very, very cool stuff. Again, go back and take a look at the videos that talk about the futures collector and how it all works. That's important for you to understand. You don't have to know how to write that code, but you have to know how to use it. And it will figure very prominently in the transform image async method. It'll figure prominently in the process images method, and it figures prominently in the crawl hyperlinks on page method. So these are all things that have sequential streams in them, and they all get collected using the futures collector stream. So that's basically the walkthrough. Hopefully you get a better sense of how to do things. If you have any questions, please don't hesitate to ask. Now that we've walked through the specification and the skeletons, let's go ahead and show how to run the tests. As usual, we come into the test folder and right-click on the EDU Vanderbilt image crawler folder, and that will go ahead and start to build and run the tests. As you can see, there's lots and lots of tests because we're running all these tests cumulatively to make sure that your old programs continue to work with any changes you make to the new versions. As you can see, there's a whole bunch of completable futures crawler 1 tests, all of which pass. There's the ones from the fork join crawler 1 and 2 tests. There's the parallel streams crawler 1 and 2 tests. There's the sequential streams crawler tests, and then all the various array collector and array and synchronized array tests. So lots of stuff here. If all goes well, you should pass all the tests, as my test program has done here. So that's a good sign. And at this point, that's the overview of assignment number 4.